One of the most fascinating phenomena in our universe happens to be related to one of the most famous theories in the history of science. And as you might have guessed, I'm talking about the theory of relativity, and the phenomenon I'm talking about is gravitational lensing.
First of all, let's start by defining what gravitational lensing is. Let's imagine a galaxy which is quite far away. We will call it our source. This galaxy is on a certain position in space. Just in front of that galaxy, there's a bunch of other galaxies which form a galaxy cluster. A galaxy cluster is a collection of 1,000 galaxies or more. So now we have this massive collection of galaxies which are obstructing our view of the galaxy behind it, which is the one that we want to look at. What happens is that light bends when it passes beside a massive object while traveling, and this warping of space and time is described by the theory of relativity. So when light from the source is traveling to us, it is bent on the way when it encounters the galaxy cluster. The galaxy cluster is acting as a magnifying lens, which is why it's called gravitational lensing. How would we see the light from the source then? The image of the galaxy we're trying to observe would be distorted. A rare consequence of this phenomenon is the amazing Einstein ring. The galaxy behind the galaxy cluster is seen as a ring surrounding the galaxy cluster, as shown in the real-life example. The following is an image from the Hubble Space Telescope, in which we can clearly appreciate the ring formed by the galaxy directly behind the cluster. Another very fascinating implication of gravitational lensing is that it gives evidence for the existence of dark matter. Dark matter is invisible matter which forms around 23% of the energy and mass of the universe, and the existence of which is accepted by a large majority of scientists. There are many calculations that tell us that there is more matter than the one observed. The composition of dark matter is not yet known since we cannot see it, as it does not interact with the electromagnetic field, and finding the particle that makes it up has proved to be difficult, although there are various candidates. The LHC in particular is dedicating a lot of time to discover a candidate for dark matter.
Now that we know what dark matter is, we have to talk about its relationship with gravitational lensing. We said that when light passes beside a massive object, it is bent. The angle of the bent light depends on the mass of the object. The problem is, in the universe, many galaxy clusters have been calculated to have visible mass which does not account for the angle of the bent light. The angle is too much, so there must be more mass in the galaxy cluster which we cannot see. That is why scientists hypothesize the existence of dark matter, and it is one of the observations of the universe which tell us about the existence of dark matter, just like the rotation curve of galaxies. Gravitational lensing is intriguing because it was key to the postulation of dark matter, which is why I chose to explain this topic. Apart from that, it's also astonishing how galaxies can act as lenses in our universe.